Hello, everyone, and a very warm welcome to today's session. I'm excited to introduce you to our topic, Module II Database Auditing and Monitoring. I'm Ms. Supriya Dubey, and I'm the coordinator here at the WIPRO Center of Excellence for Cybersecurity, part of the KIET group of institutions in Ghaziabad. In this presentation, we will explore the essential concepts of database auditing and monitoring, understand their importance in cybersecurity, and look at practical approaches to implement effective monitoring strategies. So, let's get started and delve into this important area of cybersecurity. Let's talk about user authentication methods, which are essential for keeping our digital information secure. First up, we have passwords. This is the most traditional method, where you create a secret word or phrase. The key here is that passwords should be strong, meaning they're complex and hard to guess, and they should be changed regularly to prevent unauthorized access. Next, we have biometrics. This method uses your unique physical traits, like fingerprints or iris scans. Because these traits are individual to you, they provide a very high level of security and convenience, especially with the increasing use of smartphones and biometric scanners. Then there's multi-factor authentication, or MFA. This is a more robust approach that combines two or more authentication factors. For example, you might need something you know, like a password, something you have, like a smartphone, or something you are, such as a fingerprint. Using MFA significantly enhances security because it requires multiple forms of verification. Finally, we have tokens and smart cards. These are physical devices that you use to authenticate your identity. Think of a security token or a smart card as a key that grants access, adding another layer of protection beyond just a password or biometric. All of these methods play a vital role in our overall security strategy, especially as cyber threats become more sophisticated. Combining them wisely helps us protect sensitive information more effectively. Now, let's talk about access control and authentication. Access control is really about selectively restricting who can get to certain data or resources. It's like having a security guard who only lets in authorized people. Authentication, on the other hand, is the process of verifying that someone really is who they say they are. Think of it as checking an ID before granting access. This process ensures that only authorized users can access sensitive resources, which is crucial for protecting information. It helps us maintain the core principles of the CIA triad: confidentiality, integrity, and availability, making sure data stays private, accurate, and accessible to the right people. There are several key methods to achieve this. Passwords are the most common, but they're just one piece of the puzzle. Biometrics, like fingerprint or facial recognition, add an extra layer of security. And multi-factor authentication combines multiple methods, making it even harder for unauthorized users to get in. Ultimately, these security measures work together to keep our data safe, supporting the overall goal of a robust security framework. Let's talk about role-based access control, or RBAC. This is a really effective way to restrict system access, but only to the users who need it. It works by assigning permissions based on a user's role within the organization. So, rather than giving everyone individual permissions, we group users who have similar job functions into roles. This way, permissions are assigned to roles, not to each person individually. What's great about this approach is that it significantly reduces the administrative burden. Instead of managing permissions for each user, you just update the role when needed. And it enforces the principle of least privilege, making sure users only have the access necessary for their work. Overall, RBAC helps us streamline security management and improve control across the organization, which is a key part of our overall security strategy. Let's take a closer look at access control lists, or ACLs. These are essentially tables that help the operating system determine what access rights each user has to specific system objects, like files or network devices. Think of ACLs as permission guides that specify who can do what. They're commonly used in file systems, routers, and firewalls to control access effectively. With ACLs, you can specify permissions for individual users or groups, such as read, write, or execute rights. This allows for a high level of detail in managing access, giving you fine-grained control. This precision is especially important in maintaining security and ensuring that users only have the permissions they need. So, in the context of our overall theme of security management, ACLs are a powerful tool. They help us enforce strict access policies and minimize potential vulnerabilities by clearly defining user privileges. Let's talk about data encryption. Encryption is essentially the process of converting information into a code, which helps prevent unauthorized access. It's a crucial step in protecting sensitive data. By encrypting data, we ensure both confidentiality and integrity, meaning only authorized people can access the information, and it stays unchanged during transmission or storage. There are two main types of data we focus on when encrypting: data at rest, which is stored data, and data in transit, which is data being transmitted across networks. Both are vulnerable to threats, so encrypting both is vital for comprehensive security. And importantly, encryption isn't just about security. It's often a requirement for compliance with various data protection regulations. So, it's a key part of our overall strategy to safeguard information and meet legal standards. Now, let's talk about the importance of encrypting data both at rest and in transit. Data at rest refers to any data that's stored on a device or server, like on a hard drive or in a database. To protect this kind of data, we use methods like full disk encryption or file-level encryption, which make the data unreadable without the proper keys. On the other hand, data in transit is the information moving across networks, such as when you're sending an email or accessing a website. For this, we rely on protocols like SSL and TLS, which create secure, encrypted connections and VPNs that add an extra layer of security for remote access. Both of these types, at rest and in transit, are crucial because they protect our data from breaches and theft at different stages. By encrypting data at both points, we significantly reduce the risk of unauthorized access and ensure our data remains confidential throughout its life cycle. This is a key aspect of overall data security, tying into the broader theme of safeguarding information in our digital world. Let's talk about transparent data encryption, or TDE. Essentially, TDE automatically encrypts your data right before it gets written to storage, and then it decrypts it when you need to read it. This process is seamless, meaning there's no need for any changes to your applications. It's a really convenient way to add a layer of security without disrupting your existing setup. You'll find TDE commonly used in systems like SQL Server and Oracle, which shows how versatile and trusted this method is. One of the biggest advantages is that it secures your data at rest. So even if someone gains physical access to your storage, they can't read the data without the proper decryption keys. And the best part? It does all of this with minimal performance impact, so your system stays fast and efficient while keeping your data protected. Overall, TDE is a valuable tool in our security arsenal, especially when we're aiming to safeguard sensitive information without complicating our infrastructure. Let's take a closer look at symmetric versus asymmetric encryption. With symmetric encryption, the key used for encrypting data is the same as the one used for decrypting it. This means that both the sender and receiver need to share the same secret key. It's a very fast and efficient method, especially useful when handling large amounts of data. A common example of symmetric encryption is AES, which is widely used today. On the other hand, asymmetric encryption involves a pair of keys, a public key and a private key. The public key can be shared openly, allowing anyone to encrypt data for the owner, but only the private key can decrypt it. This approach solves the problem of secure key exchange, which is a challenge in symmetric encryption. RSA is a well-known example of asymmetric encryption, often used for secure communications and digital signatures. Both methods serve important roles in our overall security strategy. Symmetric encryption is great for speed and efficiency, especially when the parties already trust each other. Asymmetric encryption, meanwhile, is essential for securely exchanging keys and establishing trust between parties who haven't previously shared secrets. Now, let's talk about SSL and TLS encryption for web traffic. SSL, which stands for Secure Socket Layer, and TLS, Transport Layer Security, are essentially cryptographic protocols that help ensure our online communications are secure. Think of them as a secure language that computers use to talk to each other, making sure that the information exchanged is private and protected. When you're browsing a website that uses HTTPS, you're actually relying on SSL or TLS to encrypt the data between your device and the server. This encryption is crucial because it prevents anyone from intercepting or reading the data in transit, whether they're trying to eavesdrop or tamper with the information. It's important to remember that SSL and TLS are the backbone of secure web browsing, safeguarding sensitive data like passwords, personal information, or payment details. As part of our overall security theme, these protocols play a vital role in maintaining trust and integrity in online interactions. Let's take a closer look at encryption algorithms, which are the backbone of securing digital information. First up is AES, or Advanced Encryption Standard. AES is a symmetric encryption algorithm, meaning the same key is used for both encrypting and decrypting data. It's known for being fast and highly secure, which is why it's so widely adopted across various industries. You can choose from 128, 192, or 256-bit keys, depending on your security needs. The larger the key, the more secure, but also slightly more computationally intensive. Next, we have RSA. Unlike AES, RSA is an asymmetric encryption algorithm, which uses a pair of keys, a public key for encryption and a private key for decryption. This makes RSA particularly suited for secure key exchange and digital signatures. However, because of its complexity, RSA tends to be slower than symmetric algorithms like AES. Its strength lies in enabling secure communication without sharing secret keys beforehand. There are other algorithms as well, such as ECC or elliptic curve cryptography, which offers similar security to RSA but with smaller keys, making it more efficient for devices with limited resources. Blowfish is another symmetric cipher, known for its speed and effectiveness, though it's less common today. And then there's DES, which was once widely used but is now considered deprecated due to vulnerabilities. It's important to understand these algorithms because choosing the right one is essential for maintaining robust security in our systems. Let's take a closer look at the data lifecycle. Managing data throughout its entire lifecycle is essential for ensuring both security and compliance. Each stage of this process plays a crucial role in protecting the data and maintaining its integrity. We start with creation, when data is first generated or collected. From there, it moves into storage, where it needs to be kept securely but remain accessible when needed. Usage is the next phase, where data is actively utilized for various purposes, and it's important to control access during this stage. Sharing involves distributing data to authorized parties, which requires careful governance to prevent leaks or misuse. Archival is about preserving data for long-term retention, often for compliance reasons, while ensuring it remains protected. Finally, destruction is the secure disposal of data when it's no longer needed, preventing any potential misuse of obsolete information. It's vital that each of these stages is governed by appropriate security controls. This means implementing policies and technologies tailored to protect data at every point in its life cycle. When we manage the data life cycle effectively, we not only safeguard sensitive information, but also ensure we meet regulatory requirements, which ties directly into our overall theme of responsible data management. Now, let's look at data roles, classification, and retention, which are key concepts in managing our information effectively. First, when we talk about data roles, we have three main types. The owner is the person who defines access policies, essentially deciding who can see or use the data. The custodian is responsible for maintaining and safeguarding the data, making sure it stays secure and intact. And the user is anyone who accesses the data, but only within the privileges they've been granted. Moving on to classification, data can be categorized into levels like public, internal, confidential, and restricted. These categories help us understand how sensitive the data is and how carefully it needs to be handled. Finally, data retention is about how long we keep data. The retention period is determined by a combination of regulatory, legal, and business requirements. This ensures we're complying with laws and also managing our data efficiently. All of these elements, roles, classification, and retention, are interconnected and support the overall goal of responsible data management, which is crucial for maintaining trust and compliance in our organization. Now, let's talk about data collection and destruction. When it comes to collecting data, the first priority is to ensure that everything is legal and transparent. We want to be clear about what data we're gathering and make sure we're doing it in accordance with applicable laws. Next, we follow the minimization principle, which means we only collect what's absolutely necessary for our purpose. This helps reduce risks and respects individuals' privacy. Moving on to data destruction, this is just as important as collection. We need to make sure that once data is no longer needed, it can't be recovered by anyone. That's crucial for protecting sensitive information. There are several methods for data destruction. Wiping involves securely deleting data from storage devices. Degaussing uses magnetic fields to erase data from magnetic media. And physical destruction means physically damaging the storage devices, like shredding or crushing them. Together, these practices help us handle data responsibly, aligning with the overall theme of maintaining trust and security in our data management processes. Let's talk about database auditing and monitoring. Essentially, this involves tracking and recording all database activities to keep a close eye on what's happening. By doing this, we can quickly detect any unauthorized access or suspicious behaviors that could indicate a security breach. It's also crucial for maintaining compliance with various legal and industry standards, ensuring we're meeting necessary regulations. Additionally, having detailed audit logs is invaluable for forensic analysis and incident response, helping us understand what occurred and how to respond effectively. Overall, auditing and monitoring are key components in safeguarding our data and supporting our broader security strategy. Let's take a look at database activity monitoring, or DAM for short. DAM tools are essential because they provide real-time monitoring of what's happening in our databases. This means we can track both the traffic going in and out and observe user behavior as it occurs. One of the key features is that they can generate alerts if they detect any abnormal access patterns. So, if someone is trying to access data they shouldn't, or if there's unusual activity, we're immediately notified. Another important aspect is that DAM tools log all SQL queries and any changes made to sensitive data. This helps us keep a detailed record of what's happening, which is critical for auditing and forensic analysis. And to enhance our security posture further, these tools often integrate seamlessly with SIEM systems, security information and event management systems. That means we get a comprehensive view of security events across our entire infrastructure, allowing us to respond faster and more effectively. Overall, DAM plays a crucial role in our security strategy by providing continuous oversight and helping us catch potential threats before they escalate. Let's talk about audit trails and logs. These are essentially chronological records of events that happen within a system. They help us track who accessed what, when they did it, where they were, and how they performed those actions. This level of detail is crucial because it allows us to understand exactly what has occurred in our environment. By maintaining these records, we can effectively trace any unauthorized changes or potential data breaches back to their source. This is a vital part of our security measures. It's also important to note that logs need to be tamper-proof and stored securely. If someone could alter or delete these logs, it would undermine our entire audit process. So, ensuring their integrity and security is essential for reliable monitoring and accountability. Overall, audit trails and logs are key tools in maintaining transparency and security, tying directly into our broader goal of safeguarding data and systems. let's talk about database security policies and procedures. These policies are essential because they set the protocols for protecting our valuable database assets. They help us define clear rules for who can access the data, how they authenticate themselves, and how data is encrypted to keep it secure. In addition to access controls, procedures are put in place for regular backups, so we can restore data if needed, and for incident response, ensuring we know how to react quickly if a security breach occurs. Audits are also a key part, helping us review and verify that security measures are working effectively. It's important to remember that these policies and procedures are not static. They need to be regularly updated to address emerging threats and new vulnerabilities. This continuous improvement is what helps us stay ahead of potential risks and maintain a strong security posture across our entire organization.